So this is the second video on using the remainder and factor theorems to factor polynomial expressions. Notice we have to be given a zero in order to use this for now. Okay, in the very near future, I'm going to show you how to find potential factors, potential zeros in another way. Okay, so we know that -1 is a zero of this polynomial, x cubed plus 4x squared plus 5x plus 2. Okay, so we're going to use synthetic division to find what the next factor is going to be, and it's going to be quadratic in this case because we're dividing x cubed by a linear polynomial, x to the first. Okay, so -1 is our zero, so that's going to go out front. The coefficients of the polynomial 1, 4, 5, and 2 are going to go inside here, and now we're going to do the synthetic division so we can find the next factor. Okay, so we want to bring down the 1. Okay, we're going to multiply -1 times 1 and we get -1. Add those two values together, we get +3. Okay, multiply -1 times 3, we get -3. Add those two values together and we get +2. Okay, -1 times 2 is -2. And when we sum those, we get a 0, which is what we should get. Remember, the factor theorem says if this is a 0, if f of -1 equals 0 or has a remainder of 0, then -1 is a 0 of the function, and therefore x plus 1 is a factor of this polynomial expression. Okay, so what this leaves us with, this is x squared, this is x, and this is the constant with no remainder. Okay, so this leads us to the quadratic factor x squared plus 3x plus 2. Now, we can factor this, so I don't have to do any more synthetic division. I don't have to do anything else. This is factorable. Okay, so what I want to do is factor that, and I get x plus 2, x plus 1. Okay, well, we already had another x plus 1 as a factor, so these are going to be the three factors of this cubic polynomial expression up here. Okay, so the complete factorization is going to be x plus 2, that factor occurs once, and then x plus 1, that factor occurs twice, so there's an exponent of 2 here. Okay, so think back to multiplicity when we were graphing polynomial expressions. Our first zero, our zeros are going to be -2 and -1. Okay, -2 has a multiplicity of 1. So when we get to -2 on the graph here, the graph will continue through there. And the other zero, -1, has a multiplicity of 2. So when we come back to -1 here, we're going to bounce off that and then continue up. Okay, so if you need to refer back to the graphing polynomials videos, that would be a good idea here. Okay, let's move on to number 4. Okay, this is a little more complicated. We've got a 4th degree polynomial expression. There's 5 terms here. In this case, we're actually given 2 zeros. We might need both of those to completely factor this. We might not. Okay, you'll know after you do the first synthetic division here if you need to keep going. Okay, so we'll get to that in just a second. So we know -3 is a 0. We know +1 is a 0. 4th degree polynomial functions, the most zeros they can have is 4. Okay, whatever the degree of the polynomial is, that's the maximum number of zeros it can have. This one might have 4, it might have fewer, it might have 3. We know it has 2, at least -3 and +1. Okay, it doesn't matter which of the zeros you begin with. You can start with -3 or you can start with 1. I chose to start with -3. Okay, doesn't matter. The process works the same way regardless of which one you choose. Okay, so let's do the synthetic division again. The coefficient of x to the 4th is 1. Coefficient of x cubed is 4. -7 is the coefficient of x squared. -22 is the coefficient of x, and 24 is the constant. All right, so we're going to bring down the 1. We're going to multiply -3 times 1, we get -3. Add those together, we get +1. Okay, multiply -3 times 1, we get -3. Add these two together, we get -10. -3 times -10 is +30. Add those together, we get 8. And multiply -3 times 8, and we get -24. Now, again, that remainder should be 0 because -3 is a 0 of this function. So this makes sense. If you don't get a 0 here, you've made a mistake somewhere within your synthetic division process. Okay, so these 4 values will be the coefficients of an x cubed, or a 3rd degree polynomial that's also a factor of this. Okay, so that leads us to 1x cubed plus 1x squared minus 10x plus 8. Okay. You want to see if you can factor this by grouping. If so, that makes the process a lot easier. Okay. This can't be factored though. So what that means is I've got this second 0 here of 1. I'm going to have to use that and do the synthetic division process again. Okay. So using the 1, using this last 0 that I know for sure, and using the coefficients of this cubic polynomial, okay, I'm going to plug in 1 here, positive 1 here, negative 10 here, and positive 8 here. Again, I know 1 is a 0, so it's going to go out front. All right, so we're going to bring down the 1, go through the synthetic division process again, multiply, add those two together, I get positive 2. Okay, multiply 1 and 2, that gives me positive 2. Add these two values together, I get negative 8. And 1 times negative 8 is negative 8. Again, because 1 is a 0, I should get a 0 remainder here, and I do. Okay, so this is going to be a quadratic expression. So I've got 1, 0, which leads me to a factor. This would be x plus 3. I've got this 0, 1, which gives me a factor of x minus 1. And this quadratic here will be another part. Okay, so x squared plus 2x minus 8. Once I get this, I want to try to factor it. Okay, this can be factored. Previously, this x cubed, this third degree polynomial up here, could not be factored, so I had to continue with synthetic division. This can be factored, so I do want to factor that. And it factors to x plus 4, x minus 2. So I've got my 4 zeros now, and I've got my 4 factors. Okay, so my complete factorization. This 0 of negative 3 gives me a factor of x plus 3. This 0 of positive 1 gives me a factor of x minus 1. And then I got these two factors from going through the two synthetic division parts here. So x plus 4 is my third factor, x minus 2 is my last factor. Okay? Because these 4 are factors, I can get the 4 zeros from there. So negative 4, I'm going in order here, negative 4, negative 3, positive 1, and positive 2 are the zeros. Notice each of these factors occurs exactly one time, so the multiplicity is 1. Again, if you need to refer back to the graphing polynomials videos, you've got your zeros, you can find the y-intercept, you can deal with the end behavior and find some test values in between to help you graph this.